Get this started. Thank you everyone for coming today. I am so pleased to see so many of you. From a social distance, we felt like we were too close together. But I will take my mask off so you can actually hear me better. We wanted to make sure we were staying safe and that all of you are as well. So welcome to our webinar, PDF Security, Encryption, and Digital Signatures. My name is Elaine Beeler. I am part of the marketing team here at iText. Morning, we have two great speakers for you. Duff Johnson, the CEO of the PDF Association, and Michael Demey, our lead researcher here at iText. A few housekeeping things that I'd like to cover for today. First, this is a recorded webinar, so afterwards we will be sending out links to the recording that you can see. They'll also be available on our YouTube channel and on our website. Today for our speakers, please, you can raise your hand and use the question function. We are compiling the questions throughout the webinar, and we'll get to as many as we can during the Q&A at the end. If we miss your question, we will actually respond to all relevant questions via email within the next week, so you will get an answer to your question either way. We also like to encourage you to share the webinar with folks, so if you find anything interesting or you want to share the link to the webinar on your own, feel free to do that on your social channels and tag us and the PDF Association. So without further ado, I'd like to kick things off by welcoming Duff Johnson to begin our webinar. Duff.
Thanks, Elaine. Hi, everyone. My name is Duff Johnson. I am the CEO of the PDF Association. I'm here today with Michael Demey of ITEX to talk about PDF security, encryption, and digital signatures. How you doing, Michael?
I'm doing great, healthy and safe here in Belgium. So I'm Michael Demey. I'm the lead research engineer at iText. And I'm happy to see you again, Duff. It's been some time since we've met up and saw each other in person, but I'm happy to be here.
Great. All right, let's get this thing started here. So first of all, quick couple of words about the PDF Association. We're an international nonprofit organization, member organization of about 120 different member companies and a number of different individuals, consultants, and so on. We're the home of the PDF industry, the starting point, the basis for development of ISO specifications for many different use cases for PDF technology. And the organization's communities develop best practice documents and resources and supervise the development of validation software and so on. So Michael, tell us a little bit. Oops. It's my fault. Michael, tell us a little bit about iText. Michael.
I was muted there for a moment. Sorry. So iText is an open source library that has been around for 20 years now. Initially, we developed it in Java and we added .NET support later on. And it's a very mature, very well-supported, popular open source implementation of PDF. The company iText came later on, and I came on board with iText 9 years ago already. As of today, we have two lines of software available. So we have a developer line, which has the trusted and well-known core library, iText. We've added a few add-ons on top of that to support PDFA, for instance, HTML conversion, redaction, etc. The latest one in that line is PDF Render, in which we can render or convert PDF files to images. Next to that, we have a business line of products with the launch of Ditto last year. Ditto is a template editor and SDK in which you can convert data and templates into a PDF file almost effortlessly. Ditto uses iText Core under the hood, so it has a very mature and robust PDF engine underneath it. You can find more information on our products and on our code samples on our website. So iText and the PDF Association go all the way back to 2012. Earlier as well than that, but we've been a full member since 2012 and the partner member since 2015. As of 2018, we also have a seat at the board of directors. And we are frequent speakers and attendees of various events hosted by the PDF Association, such as the PDF Days in Berlin. Duff and I know each other from our work at the ISO. Duff and I know each other from our work at the ISO committees. So PDF is an ISO standard. Some people might not know that. That means that the ISO committee manages the PDF specification. And Duff and I, we see each other regularly to collaborate on managing that specification with many other international experts.
Yep. Okay, great. So let's talk about what we're going to cover in this webinar today. Fundamentally, we're going to review a few of the basic document security options in PDF technology: password, encryption, certificates, redaction, and digital signatures being that range. And then Michael is going to talk a little bit about how to implement these options in iText. So let's get started. So, okay, wait for it to turn the page. Okay, so first some terminology. Encryption is a class of technology used in PDF by authors to restrict access to people who are authorized to view the document. Redaction is the process of removing content from a document in order that the document as a whole can be safely distributed, whereas digital signatures give you the capability to authenticate that the document has not been corrupted or tampered in some way, and provide other options with respect to validating that the signer was authorized and so on. So what are the use cases for security? It's all about mitigating risk, right? So with encryption, organizations and individuals are looking to guard against the loss of intellectual property or the theft of it. Governments and other formal agencies are attempting to defend their classified information against their adversaries. Hospitals and healthcare organizations and many other types of institutions are ensuring are protecting privacy, and in fact, they're conforming with government regulations regarding privacy, such as HIPAA, by restricting access to documents. And of course, everybody has an interest in protecting the confidentiality and privacy of particular documents. There are a wide range of use cases for encryption security. Redaction is a sort of niche within security that provides for the ability for users to share their documents, but to restrict the availability of sensitive content within those documents. So broadly, within redaction, you're removing content, specific content, in order to provide that the document as a whole can be shared with, for example, members of the media or with the public and so on. Digital signatures are about protecting documents against tampering, to provide assurance of authenticity and provide some validation options to ensure that everybody knows that the signer was authorized to sign the document. And digital signatures have the benefit in business communications of increasing transparency and speeding communications and allowing content or agreements to go back and forth expeditiously. So password encryption is very familiar to most users of websites and in the modern era. Probably everybody attending this webinar has in some way or form used a password in the last 24 hours. And in PDF, you can use a password to open a PDF file. The latest PDF specification supports 256-bit AES encryption. There are other options, or older options, and Michael is going to talk a little bit about that later on. Why would you want to potentially pick an encryption level that's less than the current standard supported by the PDF specification in various implementations? So along with password encryption comes in sort of two flavors in the PDF context. One is the user password that makes it possible to secure a document against opening. An owner password is slightly different, has a few limitations, but broadly speaking, once a document is permitted to be opened, the owner password provides the author with the ability to control whether or not a person viewing the PDF can, for example, add comments, fill out forms, even print the document, or copy and paste, or use the content in accessibility context. So those sorts of restrictions are applicable, but of course it's important to note that because users already have the document open, all the owner password controls are operable by virtue of a convention. It's the encryption. Once the document is basically open, the encryption from the point of view of the software is relatively bypassed. Owner passwords do something for end users, but they're not really there to guard against people who are seriously trying to leverage the document. Okay, certificate encryption is another implementation or use of encryption technology in order to secure documents. Certificates, instead of being a password that you have to know and type into an interface in order to access a document, a certificate is something you possess. You install it on your desktop computer, on your mobile phone, and once you have it in your possession, you receive a document that's intended for use only with those certificates. Then the mere possession of that certificate allows you to open the document. Certificates can be combined with password encryption so that it's possible to ensure that a user not only has to know the password, but also has to be on the right machine in order to be able to access the document. The certificate model can be extended with the use of digital identities, which leverages the certificate authority to provide additional identity management. And of course, certificates are based on public key technologies. So it's all about literally, once you become authorized for a particular class of documents, you're going to be receiving a public key from the issuer of those keys in order to be able to access this content. So redaction, for many people, redaction, they would say, well, it's not really a security technology, it's not encryption, and it's true, but it has a very vital role in the world of security nonetheless. Because redaction is the process, redaction is the process that allows an author or users or owners of a document to control specific elements of content in the document and thereby make a document that could not otherwise be distributed to make it something that can be distributed. So redaction involves the complete removal of text or images or just portions of images from a document without disturbing other content. You can, in a PDF, you can snip out a word or a paragraph or an image or a tiny little piece of an image, and the rest of the content is really present. More advanced redaction software support the ability to add redaction codes so that it's possible to indicate once a redaction has occurred in the document that the redaction's purpose was to guard against a privacy leak or to protect national security or something along these lines. Redactions can be visible. The classical redaction is like a black square or an oblong that gets applied to the document. The content underneath it is removed. But of course, redactions, there's no specific color for redaction. You could make them green if you wanted to, or you could just simply make it white and make the content disappear. There's no real rule about what redaction has to look like. It's simply about removal. So, and in PDF has a fabulous feature in the annotations model called redaction markup. And this supports advanced workflows wherein it's possible to mark up a document with redaction annotations such that after the markup has been done and reviewed and qualified and verified, a server could come along and simply apply all those redactions in order to produce a releasable document. So digital signatures are another implementation or usage of encryption technology to perform integrity checks on documents, to detect changes that might occur if a document is downloaded and it gets corrupted on the download, or to detect a change, for example, a tampering of a contract. If it's already been signed and digitally signed by an author, then if it is tampered with on the way to its recipient or before the recipient has viewed it, the recipient would be able to deal with that, or would be notified of that. So digital signatures allow for the detection of changes. They allow the recipient to authenticate the signer's identity, and that is to say, was this document really signed by this person? And they also provide for non-repudiation. So the signer has no opportunity to deny that they actually signed the document. So now I'm going to hand it over to Michael, who's going to give you some information about how to achieve these various kinds of technologies, these various kinds of features in the iText context. Michael.
Hey, Duff, thank you. Thank you for the explanation of all the concepts and terminology. First of all, I'm going to turn off my webcam because I feel that my Corona hairstyle has been on display long enough for now. Okay. Okay, so now I'm going to look at the concepts that Duff described and how to implement them in iText. So the first concept that Duff talked about was the concept of password encryption. So to reiterate, there are two passwords provided within PDF specification. There's the owner password and the user password. When using password encryption, you can also set certain permissions on a document, on a file. These permissions can also be set on other kinds of encryption using, for instance, a certificate, but we'll just look at them right here, right now. So as mentioned, there are two kinds of passwords. You have the owner password and the user password. The owner password is also known as the master password, and it's basically it says it in the name, so it's the owner of the document that sets it. This password allows you to set certain permissions, which allow or disallow certain actions to be taken by the viewer or by the user that wants to view the document. Then the user password, the name is also very descriptive. You need that to open, to use the document. If you don't have the right password for the right document, then you cannot open and view the document or process the contents of the document. This is a brief, very short excerpt from our code base. We of course, implemented all the permissions that were provided by the PDF specification. As you can see, these are based on bit flags, and you can combine a lot of permissions together to allow for multiple permissions or to disallow multiple actions at the same time. So how do you encrypt a PDF? The workflow in iText is pretty simple. There are three main steps. First, you configure the encryption, then you add the content to the document, and then you close the file. Configure the encryption is relatively straightforward. You set the passwords, the user and the owner password, then you also set the permissions, and you decide on encryption strength. Duff mentioned earlier that the 256 is the default supported by the PDF specification, and you can opt to choose, you can opt for weaker, older algorithms or strengths. And the reason why you would do that is that you might have requirements, technical requirements that have a need for lower strength, or you need to support older software or hardware or processes that only can, for instance, decrypt 128 and not 256. Adding the content is how you would add content by using iText. Normally, we won't go too deeply into that because we have lots of code samples and it would go beyond the scope of this presentation. And closing the document finalizes the document and then outputs it, flushes it to the output, be it on the stream or be it on the disk to file. So this is the first part of our writing code sample. As you can see, the permissions have been set in the first line. In this line, we allow screen readers to be used. You can add multiple permissions together by performing bit operations here into the permissions object variable, but we only chose to allow screen readers for this code sample. Next, you instantiate a writers properties object, which is going to set all the encryption information with the set standard encryption method onto our PDF writer object. So what do we pass to that properties object? We pass the user and the owner password, the previously specified permissions, and then the encryption type. Our PDF writer object will then take the writer's properties, and then it will set and configure the document, the file, to have the correct encryption settings for you. In this case, we write the file to a certain folder and to a certain file. We then instantiate a PDF document object containing the writer. We add content to the document. I've hidden away the addition of the content into a helper method because it goes beyond the scope of this webinar. And then we close the document. Closing the document flushes everything to the output stream, in this case, to a file. The result of this is a PDF file that is encrypted. Here you can see a dialog screen of a very popular PDF viewer implementation. And on that screen, you can see a securities tab. This tab also lists the restrictions that have been allowed or disallowed by the PDF producer. So in this case, printing is allowed, for instance, while commenting is not allowed. So next up, we've created our encrypted file. How do we access our encrypted file? How do we read? How do we open it? How do we process the content that's inside? The workflow is pretty simple. There are 3 steps, and 2 steps involve opening the document. So you set the password and then you open the document. It can be that simple, really. So in code, it looks like this. You create a reader object and you pass it reader properties. Very similar, very like how we did with the writer properties. And then we set the password onto that object. The PDF reader is then passed onto the PDF document. And if you've set the incorrect password to be used, then iText will throw an error here. An exception will be thrown at runtime, obviously, telling you that the password used is incorrect. If iText moves beyond this line, then the document has been opened, and then we can start processing the content. So in this code sample here, we get the first page, and then we process the content on that page. We also have to close the document here, not to flush to a disk or to a stream, but to make sure that we free up the memory that's being used by iText. So that was password encryption. If we want to move on to certificate encryption, we need to explain the concept of public keys before we look into how certificate encryption works. So when talking about public keys, we talk actually about a pair of public and a private key. So they are linked together by mathematical magic, which the explanation of that goes beyond the scope of this webinar. It would be, you could fill an entire webinar on that alone. But they are linked with each other. So what one encrypts, only the other can decrypt, for instance. There are 2 keys, the public key and the private key. The public key, the name already says it, the key should be distributed to the world, but to the public. There is no use in hiding this key from anyone. And the private key, yeah, well, that one needs to be kept private. Another important aspect of public key pairs is that they are asymmetrical. So encryption, for instance, is a one-way operation using the same key. So you cannot encrypt a message using your public key and then decrypt it with your public key again. You would need the corresponding private key. So you can never go back to the original message if you only have the public key. So this is a schematic of how it looks. It's very, very simplified. So assuming that I want to send a message to Duff, and I want the message to be encrypted. What I would do is I would take Duff's public key, or I would use it, and I would encrypt the message into an encrypted message, basically. So this is illegible to humans. It's nothing more than gibberish to us. But if Duff then uses his private key to decrypt that message, he can read the original message. This leads to a very interesting concept, because now we've sent a secret message to Duff, because only Duff can decrypt this message, seeing how his private key is only his, and he should not distribute that. If he distributes his private key, then the key pair is compromised and shouldn't be used anymore. So there are 2 concepts that we can derive from having the asymmetrical key pair. The first one is encryption. This is what I discussed on the previous slide. So it's sending secret messages to a recipient using his public key. But if you reverse the operations, if you use the private key, then you can achieve the goal of digital signing. You can sign a certain data. So data is signed with your private key and can only be validated with your public key. That means that if you can use my public key to validate the signed data that I send you, that means that only my private key signed it, from which you can then tell that the message really came from me and not from somebody else, because my public key was able to validate the information. So now that we've gone we've given a very high-level overview of PKI. Let's look how we can leverage that to encrypt a PDF file with a certificate. So the steps are basically the same as with a password, except that we've substituted the passwords with a read certificate step, which looks like this in code. So similarly, we have the permissions line that has been set here and the writer object that has been instantiated. We then set a public key encryption to which we pass the certificate that we've loaded from our system. And then we also pass the permissions and the encryption type. So it's very, very similar to how the password encryption worked. If we then want to read that same file, we would need to set on the reader properties the public key security parameters, and then pass that to the PDF reader, and then we can open the document. Again, if the document, if you load the incorrect certificate to load the document, then the document won't open. It will, ITEX will throw an exception here. So that is how to do basic encryption on PDF files. The next concept that I want to explain, or at least show you how ITEX implemented it, is redaction. So as Duff mentioned, redaction is basically removing sensitive or private data from a file in a secure way by actually removing the data and not just overlaying it with a black rectangle that can be removed with minimal PDF knowledge or by using the right tools for the job. So ITEX will remove the physical text of the PDF syntax. It will remove parts of images. It will remove images if overlaid by the rectangles that you've defined. So there are two main ways of doing it with iText. So you can add redaction annotations to the PDF files using any kind of viewer in which you mark content that needs to be removed. Do note that this doesn't really remove the content, it just marks it as being up for deletion. These still need to be processed in an automatic way to have the content removed. So this is just an interactive way of selecting what you need to remove. You can also do that through our APIs. So either you define rectangles to delete the content that needs to be deleted, or you use the abstraction that we added. For instance, we have a regex-based redaction in which you can enter a regex to find and select the text that needs to be deleted. So this is a sample of the regex kind of way to delete things. So here we've combined a reader and a writer object because we do want to read in a file and then write that to a specific file. Then we create a PDF auto sweep object. Sweep is what we at iText call redaction. So this is a class that automatically redacts PDF files. We pass it a regex-based strategy in which we want to redact the word hello. The color is black, but you can decide on that whatever you want to be. And then we tell it to clean up and to close. If we check the output, it looks somewhat like this. So on the left hand, you have hello world, which is the input document. And on the right hand, you have black rectangle world. The hello has been removed from the content and cannot be retrieved anymore from the PDF syntax. So then finally, I want to briefly touch upon digital signatures on how you would implement that in iText. So digital signatures are also a form of security. They are less about restriction of access, less about disallowing people to do certain actions in PDF files, but they are more of a focus on security of the content. They want you, as Duff explained, they want to prevent you from tampering with a document, or at least notifying the user that the document has been tampered with. And we want to make sure that the author is who we think he is, and that he cannot deny his signature, which is also a very important factor of the signatures in PDF. Imagine that I have a contract with Duff in which I give him $10,000 or euros in the next few months. He wants to make sure that I cannot deny having signed that contract because he wants his money, obviously. So We also wanted to talk about the Mueller reports. I'm going to hand over the word to Duff briefly because he wrote an article, a very interesting article on the PDF Association website about this. So Duff, take it away.
Yeah, thanks, Michael. So the Mueller report offered an interesting window into the kinds of things that could be accomplished with a kind of a modern workflow that fully accommodated the security and redaction and digital signature features that we've been talking about here. But unfortunately, it didn't. And that's sort of what I wrote, what the article that I wrote was all about. So the Mueller report, as you may recall, was issued last year from the U.S. Department of Justice. It had to do with a political investigation. My interest, of course, was about the PDF file itself that was released, and that's what the article is all about. And to bring a long story short, the Department of Justice, which handles a lot of high-profile documents all the time and is presumably well aware of workflow requirements for these things, they could have used a digital signature, encryption, and redaction tools together to deliver a really high-quality, searchable document. Unfortunately, the report was not delivered that way. The document was delivered originally on paper, when it could have been a PDF. The paper document was then scanned, it was then redacted, it was then printed, the printout was then scanned again, and then that scan was converted to PDF and posted on the Department of Justice website. The resulting PDF file was about 146 megabytes. It was not searchable, it was inaccessible, it was not tagged, so it was inaccessible to disabled users. And it was significantly not digitally signed by the Department of Justice. So anybody downstream could take that PDF and carve off a page, replace a page, and post another PDF file claiming that they had the the authentic Mueller report. So in all kinds of ways, from handling redactions to the use of encryption to prevent changes to a document, to the use of digital signatures to indicate tampering or to indicate the validity of the signer, the Mueller report represented a wasted opportunity, unfortunately. Back to you, Michael.
Okay, thank you, Duff. I do advise everyone to go read that article. It was a very interesting, it still is a very interesting article on very important events that happened last year. Okay. So to continue explaining digital signatures, I would need to touch upon hashing. Hashing is a cryptographic function to turn any kind of input data into a fixed size output. There are a few common algorithms that most of you have heard if you've got a programming background. For instance, MD5 is a very well-known algorithm. It's deprecated and it should not be used. Same goes for SHA-1, which was very recently in the news. I say very recently, but it was 2018 or 17, I think, with the research on Shattered. There was also very similar research released early this year or the end of 2019. And the SHA-2 family is also very well known. So hashing turns input into a fixed size output, and it's deterministic. Anytime you turn the same data, every time you hash the same data, it outputs the same hash, the same digest. So looking at a example here, so we have a document that's been provided on a server. If we hash that document, then we get the output string AF1B, etc. Every time we use the same hashing algorithm on that document, we will always get AF1B, etc. What you can do to check if the document has been tampered with or if the document has been corrupted during the download is you download the document and then you can generate a hash. Then the server should also provide the hash that it created from the same document using the same algorithm. If you then compare those two hashes together, if they are the same, the document has not been tampered with, it has not been altered or corrupted. If they are different, then you should investigate why this document has been changed. Maybe a corruption happened during the download, or maybe somebody made an edit to it. So let's take a quick look at how to create a signature in iText. We start by creating a PDF reader. because we want to read in an existing file here. We want to sign a file that we've had in our archive system, for instance. We then pass that reader to a PDF signer object, which also takes an output stream. In this case, we write to a file named test. We then set a certification level, which is a PDF provision on what kind of signature you're setting here. It goes beyond the scope to dive into what that means, but there is a webinar that we've done last year on digital signatures, which goes into more information about that. The second step here is to create the appearance. So we love simple namings, so we named this PDF signature appearance. You create one and then you set metadata on that, like the reason of signing, the location of signing, and where on the page the bounding box for the signature should be. You can also set the field name. ITEX does provide some default names if you don't set it, but it's always more convenient to set a name. Then we actually create the signature. So we're done with setting up the appearance, with setting up iText. So now we create the signature. We are using a private key to sign. So we do instantiate a private key signature on which we pass the private key, which algorithm to use to hash the content of the documents. And because Java uses the provider system, the security provider system, we do have to pass Bouncy Castle to that API. And then we sign the document. It's a very simple workflow that you can use to sign. On my system here, I've already pre-signed some documents, and this is one. So as you can see, this document has been signed. There is, in the signature panel on the left, there is one signature that has been signed by iText. It does have an issue, so the orange mark up there means that there is an issue with the signature. If we investigate, that means that the identity is unknown because it has not been included in my list of trusted certificates. But the document has not been modified since the signature was applied. That means that the hash of this document, of this signature, they match up, so no changes have happened to this document. The identity is unknown because we've used a self-signed certificate, if I can recall correctly, and those aren't trusted automatically. But this is what a signature looks like in Acrobat Pro, for instance. Okay, and that concludes our code samples part. I think we can move on to questions.